In our last class session, we have seen regarding kernel threads and process management. Today we will be looking into character drivers. Am I audible?
Yes, you are audible.
Any problem with sound?
No, no, no. All fine.
Okay, thanks. So in Linux, everything is a file. We know everything is a file. So even the hardware devices are a file in Linux. So these hardware devices are present in the /dev directory. So all the hardware devices files are present in the /dev directory. And we can use system calls like open, read, write on this device files. We call them as device files. Is there any echo while I'm speaking?
No.
Okay. So any problem with sound, just report me. I'm using a headset, so just want to confirm.
Yeah, sure.
So as discussed, every hardware devices is also a file. So these files are called as device files, and these are present in /dev directory. Uh, and we can use all the system calls like open, read, write, close, which we normally use on files. So these calls will be redirected to the device driver. So each and every device will have a device driver, and they expose a device file. All the open, read, write calls will be redirected to the device driver by the kernel. So there are mainly two categories of device files. One is character, other is a block. The division is performed based on the speed of data transfer, amount of data transfer, and the way of organizing the data transfer. So there are mainly two categories, character and block. The character is a slow device. It will only transfer small amount of data, and it will not have frequent queries, seek queries. Examples are like keyboard, mouse, serial ports, sound card, joystick, etc. So these all are character devices. So as character devices are slow devices, they will transfer a small amount of data, and the data transfer will happen like byte by byte. The second category is the block device, where the data is organized into blocks and will normally perform seek operations, like we normally search the data. Examples of these devices are hard drives, CD-ROMs, RAM disk, etc. So in this case, will not be performing byte by byte data transfer. Data will be transfer will happen block by block. So there are different APIs for accessing this device drivers. So for character drivers, whenever you call a system call, it will be directly going to your device driver code. Whereas in case of block devices, the drivers will not directly work with system calls. So there is an intermediate layer in case of block devices, which we call as file system. There's a file system which acts in between the user space calling system call and the device driver exposing the API. So there's an intermediate layer where in case of character device drivers, whenever you call an open system call, it will directly come to your driver call. So we'll be looking for in this course on character device drivers. S- So a character device drivers transfers data byte by byte. Examples of character device drivers are keyboard, serial port, etc. So as we said, all the hardware devices has a device files. These are present in /dev directory. So all these are device files. So each and every device file is either a character device or a block device. So how can I find out whether it is a character device or a block device? I can just say I can do an ls minus l, or I can say ll dev, and you can see if you have c at the beginning, it is a character device. D is for directory. If you have B at the beginning, it means it's a block device. So you can just do an LL on that, or ls minus L. If it is a B, it means it is a block device. Or you can say ls minus L, grep for starting with C. Or it's grep for ls minus L is not showing this. Sorry, it's not in the slash dev. ls minus L. So these are all character devices. So you can see we have lot of character devices. FB0 is frame buffer for display. Then TTY is also a character device. Then we have serial ports. All those TTY-S star are serial ports. These are also character devices. And for block devices, it starts with B. So all these are block devices. SDA1 is my hard disk. So this is a block device. Any RAM disk is a block device. So all these are block devices. So this means we have two kinds of devices. We have seen character devices which transfer data byte by byte and sequentially. And then we have block devices where data is transferred in block and we normally perform seek operations. And we search in the text a lot in case of block devices. And we can find out which is a character device by looking into the ls-l output. So we'll be looking into how to create a character driver for a character device. So these are the steps for creating a character driver, which we'll be looking in deep. First step is we have to allocate a device number. Next, we have to initialize the character device with the file operations. And then we have to register this character device with the Linux kernel. So we'll be looking each of them in deep.
Hello, Jamal. There is a still disturbance in microphone.
Is there?
Yes, a mic is coming continuously.
Okay, let me change the microphone. Just a second. So major and minor number. So the connection between, so we have an application, you have a device driver, and then you have a device file. So these are the three components when we work with character devices. You have a user space application, you have a character device driver, and then you have a device file. So the connection between the application, user application, and the device file is on the name based on the name of the device file. So the connection is between this connection is between the user application and the device file. So user application needs the name of the device file, whereas the connection between the device file and the character device driver or block device driver is based on the number of the device file. So we have two here. One is the name of the device file. The second one is the number of the device file. So this is when the connection in between the device file and the device driver. So what is this device number? It's also called as device ID. So this consists of two parts. One is the major number, second is the minor number. So a device number is divided into two parts. Major number, it identifies the device type, whether it is a USB device, whether it is a serial device, whether it is a SCSI device. So a lot of devices. So it identifies the device type, the major number. Whereas the minor number, it identifies the device. So you can have multiple serial ports. You can have multiple USB devices connected. So using minor number, you can distinguish between one first USB device to second USB device. So this is totally in a single device number. and this device number is divided into two types. So what also is the major number is used to identify the driver, whereas a minor number is used to identify each physical device which is served by the driver. So a device driver can serve multiple physical devices of the same type, like you have multiple serial ports. So for the major number, it is identifies the driver. Minor number identifies the physical device. So you can see the TTY S0. You need to, how to find out the major and minor number? Again, you have to do LS minus L. In the LS minus L, you can see the major and minor number. So the second, third, fourth, fifth column is the major number. Sixth column is the minor number. You can see two devices files can have the same major number, but the minor number will be different. There is no chance of having two device files having the same major and minor number. This it will never happen. So minor number will be different. You can see here major number is 4 for serial port, and the minor number is different for each of the serial. So certain major numbers are statically assigned to the devices. So there are some major numbers which are assigned statically by the kernel. So how can I check what all are those? In the kernel sources, there's a documentation folder. In that you have admin guide. Then there is a file devices.txt where it is mentioned what all static device numbers are being used. So there's a documentation folder, admin guide. So you can see the major number 0 is reserved. Major number 1 is for this one. And these are the minor numbers. And we have seen 4. 4 is for TTY devices. So these are all our static major number allocations. This is the major number. This is the minor numbers. So whenever you are assigning a major number or minor number, there are two ways: static or dynamic. Static means you already know a number and you want to assign this to device file. In case of dynamic, kernel will give you a device number. So the data type for device number is dev underscore t. 12, this dev underscore t is now 32-bit, out of which 12-bit are used for major number, 20-bit are used for minor number. So this is total 32-bit. So given a major device underscore t, I can get the major number using a macro known as major. I can get the minor number using a macro known as minor. If I have both major and minor, I can create a device underscore t using mkdev. The header file for this macros is this. So you can see I have included the header file, and I've created a member of dev underscore t. I'm using macros major and minor to print the major and minor from dev underscore device number. Just give me a second. Okay, let's continue. So we am creating a device number of dev underscore t. Then I'm printing the major and minor using major and minor macros. Then I am giving major and minor number to mkdev. This will give me the major and minor. It will create me a device underscore t, and then I'm printing the major and minor of this. So it's giving a warning saying device number is uninitialized because we are trying to use device number here without initializing anything. So I can also write like this. So I can assign a number directly to device number like 49. So you can see in the initial case is 0 and 0. In the next case, when we give 49, the major number is 0 and minor number is 49. In the next case, where we have given major and minor to mkdev, it gave us the device number. So there's a file in proc file system, proc devices. This file will give you the various devices which are already present on the system. So proc devices is a file which will give you the various character and block devices present on the system. So this is divided into two sections. One is the character section, and the block section. So this is the output of cat on proc devices. You have the major number here and the name of the device. You can see a single major number is having multiple names. And this is divided into two sections. One is for character and is for the block device. So now how can I allocate a major and minor number? There are two ways, static and dynamic. So when should we use static and when should we use dynamic? Static is useful if you know the number in advance, like if you know what is the major number you want to use. In case of static, you tell the kernel the device number. I want to use this device number. In case of dynamic, you ask kernel to give a device number. So this is the difference. So the best case is always to use the dynamic because you never know which all devices are already being using the device number. So if device driver is already using a device number, there will be a conflict. That's the best option is to always use dynamic method. So let's see how can I use static. Like I have a device number. I want to use it for my device. The API for using the static is register underscore chr region.
It accepts three arguments. First one is the device number. How many devices you want? So number of consecutive device numbers required. And then the name of the device, which you want to be appeared in proc devices. This is for static. And in the module exit, you have to unregister this using unregister switchout abuse. Let's see some code. What I did is I have used module params so I can change the parameters of the API easily. I have created for major number, minor number, count, and device name. So first, the default major number and minor number are 120 and 0. I use mkdev and create a device number. I just print the major and minor number from this device number. The default value of count is 1. The default value of device name is my caddy. So I print it here in the init function. I call the API to register this for my driver. I pass the device number, which is created here. I have the count and the name. This name will appear in proc devices. In the exit, I unregister it from this. So you can see the default values have been printed and the device number got registered. I can verify this in proc devices. So 120 is for our own device. I remove the module and this is gone from proc devices. Let's pass some arguments. So we can see the arguments in module, so what all we can pass. So we can change the major number and minor number. We can change the count. We can change the device name. I use a different major number. So I have passed, instead of major underscore number, I have passed major. It took the default argument. So it says unknown parameter major ignored. So I have passed the wrong parameter. You can see now it's 123 is here. Let's say the device name. We got Linux here. So what do you happen? What do you think will happen if I say pass 10 to the major number? Will it accept? Again,
Yes.
10 is already being used by MISC.
Yes.
Yes.
So let's try passing major number 10. The device number registration came. So the registers here have the 10. So if a major number is already being used by a device driver, we cannot use the same major number. So this is why static method is not preferred. So what happens? Suppose I have USB as name for the major number 180. I will use a different major number which is not present here, but I will give the same name USB. Let's see whether it will work or not. So one USB name is already being used. I will give a different name. I will use a different major number and I will give a name which is already present. So it is fine to use the same name which is already present. So you can see the name is same in both major number 123 and 180. This means only the major number should be unique. You can have the same name for different device drivers. So you should make sure the device number is major number should be unique for your own device driver. This is the reason we use dynamic device numbers. So what is the maximum minor numbers we can have? So we know minor number is 20 bits and major number is 12 bits. So what do you think will be the maximum minor number? So this is the maximum minor number. So if you open a calculator, two power is this value. So this is the maximum minor numbers for a particular major number or particular device number. You can have this many minor numbers. So I'm trying to allocate that many minor numbers. So I'm trying to allocate like this many device numbers. So one device number means a combination of major number and minor number. So we got it without any problem. We were able to allocate so many device numbers. What happens now? So I set the initial major minor number as 10. This means the major and minor number combination will overflow and a new device number should also be allocated for this. Like major number 126, minor number 10 is the starting device number. Then I am saying allocate this many device numbers only. So let's see now. So you can see it has allocated for 126 and 127. So what is the maximum major number which we can have? What is the maximum major number? We know the major number is 12 bits.
4096.
Okay, let's try 4096. We cannot have 4096, right? So it starts from 0 and it will end at 4095, right? 2 power 12 is not 4096. 2 power 12 is 4095. So suppose if I give 4095, which is a maximum major number as per the theory. So it says the device number registration field. The major requested is greater than the maximum. So it means the maximum limit provided by the Linux kernel is 511. We cannot have, even though we can use the major number is 12 bit, which means we can have 4095, but the Linux kernel has a limit of up to 511. We cannot go beyond 511. For now, they have put a limit till 511. You cannot have a major number more than 511. So you can open this file, Linux file system. So in this, there is a macro known as major max, and it is set to 512. So this is the maximum we can have. So till 512 means 511 is the last. So try to allocate 512 also to this as the maximum, and you can see it's freezed. So we need to restart again. Do you have any questions till here?
Right now, the module was busy. Are you able to successfully remove the module?
So the module was not successfully removed, but I believe we can remove this module.
Okay, the same problem I was facing. It was not removing since I used the same command only.
So you tried using you have allocated a major number of what was your major
No, no,
number?
it was not a major, but simply I was loading the kernel only. It was busy in somewhere. It was not working when I use RM mode.
Yeah, once you get uh, a module is in use, you cannot remove a module like you have.
Okay,
Like
okay.
like you have like used you have written -1.
Yes, yes, yes. It was -1 after it was busy in
Yeah,
somewhere.
then we will not be able to remove it.
Okay.
When in case of like -1, when you have init function, right? If you
Okay.
return -1, the module is not loaded. So,
Okay.
but
Okay.
due to some problem, your module is loaded, and you have
Mm.
some problem when you are doing RM mod, like your exit function has some problem.
Okay.
Then you cannot remove the module.
Mm.
So have you guys tried the assignment? Like started doing the assignment? If you have any queries in the assignment, you can always ask me. Can ping me.
Yeah, sure. Is it possible ki like device file having same major number? Hello?
What about the minor number?
No, no. I'm asking about is it possible ki like a device file having a same major number?
Yeah, major number can be same, but the minor number should be different.
Okay, so we but just some time ago we seen that we can't assign a same major number, right?
Yes.
So how it's possible ki like major number is not same, but it's possible ki major number would be possible, both are same. So practically we won't assign, but it's having same. So it's how?
So a device number is a combination of major and minor. So you can have a device number like major number is 180,
Okay,
minor number is 5.
okay.
The other driver can use 180 and 6.
Oh, okay, okay.
And one more thing is you have a block device driver and you have a character device driver. So you can have a block device driver using 5, and you can also have a character device driver using 5. So both are different spaces. So you can see here 7 is used by VCS in case of character,
Mm-hmm.
and in case of loop, 7 is used by block devices.
Yeah, just minor number should be different, right?
No, here in this case, it's totally different. If it is a block, you can use. So you can have
Okay,
a 7 major number, 0 minor number for block devices. You can have a 7 major number and 0 minor number for character device. But you cannot have same character device driver using major and minor combination.
okay, okay.
So we have seen static allocation. When we have seen the problems with static, if there is already the same, then it will not allocate a dynamic number for you. It will not allocate a device number for you. So we have to, the preferable way is using dynamic. And the API for that is allocs hrdev underscore region. And you can see it is a pointer here. In the previous case, it was not a pointer. So this is here is the output parameter. So the kernel will fill you the device number. The second argument is you have to give the minor number. What will be your first minor number? And how many device numbers you want, and what is the name which you want in the prop devices. And the code is same, and we have changed the API here. We are using allocs hrdev region, and we are passing the pointer to the device number here. And we also need to pass additional parameter minor number. Once we get this is successful, we are printing the major number because the major number is being allocated here. We are already telling what should be the minor number here. So it gave us 240. Two forty is here. So let's remove the module. API for removing is same. We have the same API for removing the unregistering the device number. It's gone. So let's try allocating it again. We get back again to what? I have a question now. Like if I copy this KO file into another file like this, will I be able to load this?
No.
Why?
There will be no mod info for this.
I have the mod info, right? Now you can see the mod info and you can tell why we cannot.
Because in a make file we are doing for hello.ko.
Okay, but I have copied it, right? I said I have copied hello.ko to hello1.ko.
Mm,
So let's try loading what it says.
okay, sure.
Could not insert module file exist. So we are giving this module name hello. The name of the module is hello. You can see there's a field name. So this is the reason when I try to install hello1.ko, it checked this name exists in the global space of modules. As it already exists, it failed. So even if you copy and do this, it will not work because the mod info has the same name in both of them. Is this clear?
Yes.
Give me 5 minutes. Here in this code, the same code, I'm running a for loop for 512 times. And then I'm checking the major number. Like how is the dynamic allocation happening? Like first time it is giving me 240. What it will give me the next time? Then after each and every allocation, I'm doing a sleep for like 1 second. So M sleep is millisecond sleep. So 1 second of sleep. So let's run this code. So I'm saying dmesses minus wh. I'm keeping this in background. So you can see it started at 240 and went till 234, and then it started at 511. It will continue like how many you ask. Let it continue now. You cannot stop this. Let's see the prop devices. So you can see from 240 till 234, and then started from like 511. It will go till what? It will go. So this is the code how it works. So initially it is having, it starts from 240 and it will go like till 234. This is the dynamic. There are two segments here. This is the first segment and second segment. So starting point we don't know. You can get any starting point. 240 is just an example. But the end point for this is 234. So dynamic allocation, the first segment is till 234. And the second segment starts at like 511 and goes to 384. So this is in the reverse order. Like here also you can see from 240 to 234. Here also it's like 511 to 384. So should be still allocating like 420 and all. This is the code which is present in the for the allocation. fs caddev.c. First to look in the first segment, then once it is not found anything, it will look into the second segment. So the second segment ends at 384. So see after this it starts failing. So you can update the code to return minus so that your driver will not be loaded here. Otherwise, you will not be able to stop this mode. You cannot stop the IMS mode. So we have seen the device number, which is the connection between the device file and the device, the connection between the device file and the driver. Device number is the connection between the device file and the driver. So how to create this device file? We have seen the device number. How to create the device file? There are two ways. One is manual, second is automatic. How can I create in manual? There is a command for creating the device file, mknode. So mknode -m, m is for permissions, and this is optional. And the name, device type, whether you want a character device or a block device. Then the major and the minor numbers. So here you're linking the device file with the device driver. So device driver will register the major and minor number, and then you create a device file, creating connection between the major and minor number and the device file. So example is like this. mknode -m is for permission. Name of the file. C is for character type, major number and minor number. So it's still running. It's running the 512 loop. So it should take like 512 seconds to stop this. So we can then run this. So mknode and you can see a def file is created with the permission which we have told it. Major number is 244, minor number is 10. So what did you observe here? I have not registered 244 and 10 here. So I have not registered any driver. So there is already a driver here using HMM device. For the major number 244, we already have a driver. Suppose I have 227, which is not already registered by any device driver. But I can create a device node for 227. So it already exists. Now 227 is not having any device here. You can observe it in proc devices. But I have a file created. So device file here is independent of device driver. So you can create the device file before actually loading the device driver, or you can also create it after loading your device driver. So when you are doing a manual approach, you have to manually delete the files. So let me restart it again. We have seen the manual way. Let's see the automatic way of creating device file. So initially, the device nodes were stored in /dev. So for each and every type of device, there was a node, whether it actually existed or not. So this was the older mechanism. Whether the device exists or not, they created a /dev node for the device. So the result was this directly took a lot of space. So the new way which they came up with known as udev. They came up with a new way called as udev. So udev only will create a node when there is a device. So it will use sysfs and then it will create a node. So you can use udev, you can write rules for udev, for the permissions and the file name types, etc. So for this, for our driver, we have to expose to /sys for the device node to be automatically created by udev. So we have to expose information to /sys. For this, we have two APIs. First one is class underscore create. So this class underscore create will create it will return as a class pointer which is used later. So you have to pass the struct module owner. This is this underscore module, and then you have to pass a name to this class underscore create. So this is present when you, whatever the name you pass, it will create in this class name. So class underscore create will create in this class name. So first, if I want to do a automatic device node creation, I have to expose information to this. The first API which I have to use is class create. I have to create a class in this class by calling class create, and I have to give a name. But to remove this class, I have to call class destroy. So simple code, I say class create, owner is this underscore module, the name of the class is my class, and the exit I say class destroy. So you can see ls is class. These are the different classes which we have. If you want to see what is happening in udev, what at all udev is doing, this is a command for the udev ADM monitor. This will see you can see in real time what at all what udev is doing. You would have ADM monitor. So let's run UDEV ADM monitor. So, and now let's try to load our module. You can see now there were events from kernel. So a new module hello was added. So in sys module, this is created and a new folder in class. So now you can observe this is sys class my class. A new folder is created in this class. As we said, the name of the folder is my class. It got created there. And I remove this is gone. You can see remove events from kernel and UDEV is removing it from there. So first API is class underscore create. So when you say class underscore create, it will not create a dev node. So how to create a dev node? There is a other API. To create a dev node is called as device underscore create. It accepts lot of arguments. First one is the class. This is the return value of class underscore create. Whether we have any parent device node, then we have device number. So here we are passing the device number. Any driver data, private data, and the name which you want to create. We have these all arguments which we need to pass. Like class destroy, we have device underscore destroy, and we have to pass class and device number. So I have like creating two device numbers, major number 200, minor number 1 and 2. First, I'm creating a class, and the return value I'm using in device create, and I'm passing the device number here. You can see I'm saying no parent, no data here, and I'm saying the device name should be my device 1, my device 2. In the exit, I'm destroying the devices and class. You can see now. So we have 4 kernel events here. To this 4, UDEV has created module folder in this class folder. Inside class folder, he has created my device 1 and my device 2. Let's go in this class, my class. You can find we have like 2 folders, 2 files, my device 1 and my device 2. Let's see in dev whether we have my device. Yes, we have my device 1 and my device 2 automatically created, and your module is loaded. And a major number is 200, which we said, minor number is 1. Major number 200, minor number is 2. So when we remove this, the device nodes are gone. So we have now automatically created device nodes in the init function and removed them from the exit function. So this example combines whatever we have done till now. So first we are creating a class. We are dynamically asking kernel to give a major number using alloc chr region. And then we are passing it to device create. So it will create a device of this name, or you can say here, device name. The device name is here. So we can add a module param for this. So you are using the device number written by alloc chr. and then you're creating a device node by using device. In the exit, you're doing the reverse operation. So let me do a DNS minus WH. So it gives us a 240 major number, and we should have a device node there for 240. So it has automatically used the allocated number given by the kernel. So this is how the device node can be automatically created using class underscore create and device underscore create. And this is handled actually by the udev running on your kernel or your system. So you have any questions till here?